Good morning, everyone. At least it's morning for me. This is one of the snow days I'm here at school, or the cold days there. You guys are going to be working with solving trig equations, and they're going to be of this format. And so I need to work with you particularly as the value of b starts to change. That's what's really going to be new. So let's say I start out and there's going to be two different cases or scenarios. The first one I'm going to work with you on is when the value of b is 1. So in other words, this number here is a 1. Okay? If I gave you this as the question, you go, oh, cosecant is related to sine. You cash it in. First off, you'd have sine of theta is 1 over negative square root of 2. Then you rationalize it and you get this. Sine is your y value. So you're thinking on the unit circle. Where's your y value? Negative. Okay, it's negative down here. Negative square root of 2 over 2, so you're here and here. Your two answers are 5 pi over 4 and 7 pi over 4. Let me go back up and explain this. If I write that on a number line, 0 to 2 pi, this bracket, you guys should remember from last semester, is a closed circle. 2 pi is an open circle. I'm looking for all the values between 0 and 2 pi. That's what that says, where you can include 0 but not 2 pi. Okay, so all the answers between 0 and 2 pi. Those are the two answers that work. Okay, now you're not going to see why I'm going to do this for this first example, but I'm going to bring it up because it's going to help you with the future examples. I put in the left side, whatever the left side is, right there, and the right side, there it is. And I graphed it between 0 and 2 pi. So you can see there are two intersections. This here is negative square root of 2 over 2. This is the left side, which was sine theta. Okay? There are two intersections showing you where this equals that. And those values are 5 pi over 4 and 7 pi over 4. There are two answers to it. You're going to need this idea when we start looking at other ones to help you see how many answers there's going to be. Okay? All right. So now we're going to change it up, the different scenario where b is going to be greater than 1. Now this means b is a positive rational. Again, that means b is going to be a positive fraction. You're not going to get some funky values like pi sitting right here, or say the square root of 7 sitting right there. No. Okay? So just like in the previous one, I'm going to cash cosecant in for sine. So the initial cash in, the initial thing you're going to turn in, is 1 over negative square root of 2. Then you have to rationalize it. So that's where I came up with this. Don't utilize, well, first off, if I gave you guys square root of 2x is equal to 8, can I divide out that 2 right now? Absolutely not. You have to get rid of this function, this square root, before you can touch the 2. Same thing here. I can't get rid of this 2 until I get rid of the sine function. Okay? I'm not going to inverse sine both sides. I'm just going to look at it as the unit circle. This whole thing is asking you, where's your y value? Negative square root of 2 over 2. Well, we just did that. But when I strip off the sine, that leaves me 2 theta equals 5 pi over 4 and 7 pi over 4. I need to get rid of this 2. I need to get rid of this 2 by multiplying by half on both sides. The half distributes in and gives you 5 pi over 8 and 7 pi over 8. Okay? Now you're not finished. But let me go back and review with you what I just did. I cashed cosecant in for sine. Then I asked, where is your sine equal to negative square root of 2 over 2? Where's your y value? Negative square root of 2 over 2. And just like in the one I did in the previous page, your y values are negative below this horizontal axis. They're dealing with this, a square root of 2, so they have to be both of these values here, which are 5 pi over 4 and 7 pi over 4. But that yields 2 theta equals that. I don't want to know what 2 theta is. I want to know what theta is. So I have to multiply both sides by half to get rid of that 2, which generates the 5 pi over 8 and 7 pi over 8. Now that's 2 of the 4 answers. Now, how do I know there's supposed to be 4 answers? Well, go back and graph it, just like I was telling you in the previous problem. Sine of 2x, that is 1 period right here. That's 1 full cycle. And you guys can see it's going to cycle again between 0 and 2 pi. So there are going to be, let's change colors, 1, 2, 3, 4 answers to this problem. These 2 answers here are these 2. 5 pi over 8 and 7 pi over 8. I need to find these other 2 answers. How do you do it? Well, here goes. Where's the line? There we go. There's a line. I want to segment and I want to color it red, so here goes. Okay. This distance was 0 to 2 pi. So this distance, whoops, that's not what I wanted. Boink, 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 is pi. Okay. 0 to 2 pi. So this distance, which is half of that, must be pi. Okay. This answer here was 5 pi over 8. And that one was 7 pi over 8. What I need you to see is this answer is going to repeat itself pi units later. And this answer, 7 pi over 8, is going to repeat itself pi units later. So I have to take 5 pi over 8 and add pi to it to get the other answer. And you take 7 pi over 8 and add pi to it to get the other answer. Now, how do I know I need to add pi to it? How do I know that that number is the number I need to add? Well, back before we talked about this number here, the value of b changes its period. For sine and cosine, the period of a function is 2 pi over b. This is the period. Okay? 2 pi over 2 is pi. The other answers are going to appear pi units later because it's going to recycle itself pi units later. So this distance over, it's going to repeat the answers. Okay? The answers are going to repeat. So how do you guys do that? Well, you need to get a common denominator. I've got 5 pi over 8, and I'm going to add pi to it. Well, the common denominator is 8, so 8 pi over 8 is still worth pi. I've got a common denominator, 13 pi over 8. There it is. 7 pi over 8 plus 8 pi over 8 is going to be 15 pi over 8. That's how I get the other 2 answers. Okay? So, you find the initial 2 answers, look at its period, add its period on. Okay? Another example, say I have cosecant of 3 theta is negative square root of 2. Cash it in. So I have sine of 3 theta is negative square root of 2 over 2. This much is your y value. Y is equal to that value. Where does it happen? Just like on the previous 2 problems, I've got 3 theta equals 5 pi over 4 and 7 pi over 4. Multiply both sides by a third to get rid of the 3. And you get 5 pi over 12 and 7 pi over 12. Looking back up here, you can see there's 1, 2. That's 5 pi over 4. That's 7 pi over 4. But then I've got these other multiple answers. How do I find them? I'm going to add its period on. This is the 1 period added on. This is 1 period added on. From here, if I add another period and add another period, I'm going to get the other answers. So here goes. I said in the previous page, 2 pi over b is your period. Whoops. So b is 3. So I have 2 pi over 3 is the period. I need to add that onto 12ths. So I need a common denominator. So I'm going to multiply by 4 over 4, and so I get 8 pi over 12. I need to add 8 pi over 12 onto these. So I usually do it vertically. I'm going to add 8 pi over 12, which gives me 13 pi over 12. I need to add 8 pi over 12, and I get 21 pi over 12. Now, how do I know when to quit? I mean, I could just keep going, 29, and then 37, and so on, over 12, pi over 12. Well, I said on the first page I wanted all the answers between 0 and 2 pi. If I'm dealing with 12ths, that's 24 pi over 12. That's as far as I can go. If I add 8 pi over 12 onto 21 pi over 12, I get 29, which is beyond 2 pi. So you need to quit right there. Then you start with this next one and start another column. 7 pi over 12 and, 8 pi over 12 gives me 15 pi over 12. Add 8 pi over 12 onto this. So this one is the 15 pi over 12. Add 8 pi over 12 onto it and you'll get this one. So then I get 23 pi over 12. That's all the answers I can get. There's 6 answers, and if you look 1, 2, 3, 4, 5, 6 at the graph, there are 6 intersections. Okay? Now, before I quit, these are going to work if I change this to cosine. Cosine of 3 theta is, say, a half. Well, you just ask, where is your x value a half? X is a half. X is a half here and here. So you'd have pi over 6 and 11 pi over 6. Oh my gosh, that was difficult. But it's 3 theta is going to be 11 pi over 6. And I don't know why I started there. Oh my gosh. Again, the snow day that I'm here, and they were playing music in the hallway, and it's distracting me. I apologize for being such a scatterbrain. Okay, this is what you got. Then you need to get rid of the 3 by multiplying by a third. So that would give you the pi over 18 and 11 pi over 18. You'd graph it, you'd look at it, see whether your other solutions are, and then start adding its period on. 2 pi over 3 and start adding its period onto these things. Okay? So that's how you do the left column of the worksheet that goes with this. Okay? Second part of the assignment will be out of the book, which you won't need a second video for it. Third